Principle of mathematical induction. Given 1 plus 2 plus 3 plus dot dot plus n is equal to n into n plus 1 by 2. This one I have considered that this is statement S. Now by mathematical induction we have to prove that this equal to this is true. Now the rule is, let it is true for this one. Equation 1, let equation 1 is true for n equal to 1. So if you consider n equal to 1, then one term. And here in place of n you put 1. So here one term means 1, LHS is 1. And RHS, here if you put 1, then 1 into 1 plus 1, that is 2 by 2, 2 to cut, that is 1. That means LHS equal to RHS. So it is true for n equal to 1. Now step 2, let equation 1 is true, it is true for n equal to 2. Now if you take n equal to 2, that means this 1 plus 2. 2 terms you have to take. So LHS is coming 1 plus 2. That is equal to what? 3. And RHS, in place of this, we have to put 2. So 2 into 2 plus 1 by 2. So this 2 to cut, 2 plus 1, that is 3. So 2 into 2 plus 1 by 2. 2 to cut, it is coming 3. So it is true. You see LHS equal to RHS you have got. Now next step, let 1 is true for n equal to m. You have to consider this, that n equal to, for n equal to m it is true. That means here in place of n you are putting m. See here you are putting m. Here also you are putting m. So m into m plus 1 by 2, that put here. Let's say this is equation number 3. You consider it is true. Then after considering this n equal to m, we have to show that it is true for, n equal to m plus n. So it is true for n is equal to m. So if you put n is equal to m plus 1. Now see, here we have to put in place of n, first it is m, then m plus 1. That means one term extra. This term is extra. Okay. So right side you put n equal to m plus 1. Here also n is equal to m plus 1. So m plus 1 into m plus 1 and last plus 1 by 2. Now see, up to this is a formula. By this here you see, by 3 we can tell that 1 plus 2 plus 3 dot dot m equal to m into m plus 1 by 2. So here you put m into m plus 1 by 2 and at last m plus 1. Now here if you take m plus 1 common, then here it is m by 2 and here 1, m by 2 plus 1. Now if you do LCM here, then it is coming m plus 2. M plus 2 means m plus 1 by 2. Now see right hand side here also, you see this m plus 1 into m plus 1 plus 1 by 2. That means we have got RHS. So we have got it is true for n is equal to m plus 1. Therefore, by mathematical induction, we can tell that the statement considered is true for n is equal to m plus n. All the sums we have to follow this technique. That's all. Okay, once more I am telling that first you have to consider the statement, consider the given thing as a statement. Then step number 1, you show n equal to 1 it is true. Step number 2, for n equal to 2 it is true. It is optional. And then for n is equal to m it is true, you consider that let it is true. After that you have to show that the statement is true for n is equal to m plus 1. If you can show, then by mathematical induction we can tell the statement is true for n equal to m. I mean n equal to all integral value of or integral value. That is why the statement is proved. That's all.